So I'm back today to show you and discuss with you the characteristics of metamorphic rocks. Metamorphic rocks are a rock that undergoes a metamorphosis. A metamorphosis is a change. Metamorphic rocks come from pre-existing rocks that have already been in a location. There are two processes that make it: heat and pressure. Heat from nearby magma or lava. Now, if you know anything about rocks, we know that igneous rocks come from magma or lava. But it's the heat that's going to be given off by that magma or lava that will change the rock. And I'll get into that in a moment. The pressure is mostly going to come from intense convergent plate boundaries that are going to cause rocks to get altered. So I have a piece of shale in front of me. And if you know anything, again, about rocks, that's a sedimentary rock. Well, the reason why I have this rock is because if you kind of put this on its side, I'll focus the camera here, you can kind of see that these shale layers, okay, have kind of an arc to them. That just represents that there are some metamorphic processes happening. This is what we call folding. So we definitely have a little bit of a fold in this sedimentary rock. Another indicator that metamorphic rocks are going to be occurring and maybe a metamorphic process is happening, okay, again, is in this piece of slate. This slate has a much more extreme fold in it. So you can kind of see you have kind of an upward fold here. If I continue over, okay, I have a really kind of exaggerated downward fold here as well. So this piece of slate, which is a metamorphic rock, shows kind of evidence that metamorphic processes are happening. And the last little sample that I have here to show you some deformation within the rock is a sample that actually has a fault in it, a break in it. So if you look at this rock layer here, and if you look at the continuation of that rock layer, they're offset. The left side is going up, the right side's going down. That's what we call a fault. When you get movement within a rock, there's definitely a little bit of a fault here. Again, evidence of crustal deformation. Now, deformation is going to happen in many different forms. But what's going to happen here is that we are going to begin this deformation process with a sedimentary rock. And I'm going to begin this whole little process here with a sedimentary rock called shale. If you've seen my sedimentary video, that video I showed you this rock here. So shale is a very weak sedimentary rock made of clay fragments. But like I mentioned earlier, if you undergo heat and pressure and you show that onto a rock, that rock is going to start to metamorphose or it's going to begin to change. Shale will change into a rock called slate. So shale undergoes heat and pressure. It will change into a rock called slate. Now, slate and shale look very similar. You'll start to see that slate has a little bit of a sparkle to it, and that just means that this is a foliated rock. Foliated rocks just means that the minerals at the microscopic level in this case are starting to align themselves up. That means that they're starting to put themselves in a row basically. Now, very hard to identify the slate because the crystals are so tiny. This is the lowest grade of metamorphism you can get. This is the first metamorphic rock that's going to form in our series that I'm going to show you. So slate is going to come from shale. Now, if you put slate underneath a little bit of heat and pressure, it will turn into a rock called phyllite. Phyllite, you'll notice, has a little bit more of a shine to it because more heat and pressure is going to indicate that you're going to have a little bit more mineral alignment, a little bit more foliated. If phyllite undergoes more heat and pressure, that is going to change into a rock called schist. Now, this is a nice piece of schist because it has some garnets in it as well. So again, very sparkly here just because the crystals are getting bigger and they're starting to align themselves up even more. Schist undergoes heat and pressure. That's going to change its look into a rock called gneiss. So yes, this is a gneiss rock. Gneiss is going to be kind of the poster child of metamorphic rocks, especially the foliated rocks, because of the fact that it has these beautiful crystal bands. The crystal bands indicate that you had tremendous heat and pressure exerted onto this rock. And what happens here is you end up getting these recrystallized rows or bands of crystals within the rock. And this is kind of the telltale characteristic that's going to be found within this rock that you can identify that this is a metamorphic rock. This is the highest grade of metamorphism you can get. If this undergoes any more heat and pressure, what would happen is this would turn into an igneous rock. This rock would eventually melt and turn into igneous as part of the rock cycle. Now, granite and gneiss are both made up of crystals. There's just a big difference between their look. Granite has crystals, but there's no pattern. Gneiss has crystals, but they are in a pattern. Igneous rocks have interlocking crystals, while metamorphic rocks have crystal bands. Now, that's the difference between an igneous rock like granite and a metamorphic rock like gneiss. Now, also, do not get mixed up with these crystal bands and sedimentary layers. Sedimentary layers are strictly a sedimentary characteristic. These sedimentary layers are layers of dirt, sediment, sand, silt, clay, whatever these sediments are going to be, and they're horizontal. Don't get that mixed up with the horizontal crystal bands within a metamorphic rock. Gneiss has crystal bands, while sedimentary rocks have sedimentary layers. Very important to know the difference between the two. Now, those are your foliated rocks, and they're primarily going to be created by intense pressure and definitely some heat. The non-foliated rocks, they're going to be made primarily by intense heat, made by nearby magma or lava. Now, some of these non-foliated rocks I'm going to show you are going to be formed from regional metamorphism as well, okay, from the plate boundaries, like convergent plate boundaries. One thing about these non-foliated rocks, they're not going to show mineral alignment. That's why they're called non-foliated. Now, the one thing about this is that metamorphic rocks have got to come from rocks that are already there. Those rocks are called parent rocks. So anthracite coal, which is a non-foliated metamorphic rock, is going to come from the parent rock bituminous coal. This is all in your reference table. Anthracite coal, metamorphic, is going to come from the sedimentary rock bituminous coal. Again, they're non-foliated, no mineral alignment. The non-foliated quartzite is going to come from the parent rock sandstone or quartz sandstone. So quartz sandstone, again, is a sedimentary rock. Quartzite is going to come from the quartz sandstone. So quartzite is a non-foliated rock. It's going to come from the sedimentary rock sandstone. Marble, which is a very common building stone, is going to come from that is a non-foliated rock. That is going to come from the sedimentary rock limestone. So marble is going to come from the parent rock of limestone. Now, if you watched my sedimentary video earlier, you will have known that limestone is made of calcite. If marble is made from limestone, marble must also have calcite in it as well. So the one thing I'm going to do is I'm going to put hydrochloric acid on all three of these to show you the reaction that's going to take place with the hydrochloric acid. The one thing I just need to do is I need to just kind of expose an inner part of the marble because the reaction ends up being a little bit better. So what I'm just going to do here is I'm just going to take just my hammer here. I'm just going to just kind of tap the edge, kind of expose a little bit of the marble to the hydrochloric acid. So just kind of chipped off a little bit at the edge here. I'm going to put some hydrochloric acid on the calcite, and it reacts. I'm going to put some on the limestone, and it reacts. And I'm putting some on the marble right there on the edge, and that's reacting as well. So because the marble and the limestone are both made of calcite, all three of them will react with hydrochloric acid. Now, I do not have metaconglomerate. Metaconglomerate is going to be a metamorphic rock that forms from conglomerate. So conglomerate would be the parent rock, Okay, I do not have a sample of metaconglomerate, but metaconglomerate is going to look like conglomerate because it's going to have these stretched pebbles. Okay, so conglomerate will be the parent rock of metaconglomerate. The only one real oddball rock that's on the metamorphic rock chart is a rock called hornfels. So hornfels can actually come from any other type of rock. Hornfels could come from limestone. Hornfels could come from sandstone. Hornfels could come from granite. Hornfels can come from any other type of rock. The unique thing about hornfels is that it's only made through contact metamorphism. Hornfels is only going to be made through the contact of nearby magma or lava, and the heat is going to bake the old rock into something brand new. So with that being said, you really have to just make sure that you can identify gneiss. That's really the really important rock that you're going to want to be able to identify visually. And with that being said, I hope you kind of learned something here. You can review something. Please watch this over again. Good luck with your studies, and we'll talk to you soon.